What's up, guys? Another episode of Poncho's Calculus.
Alright, so that was a good effort. Alright, you guys, so now 3.3 derivatives, inverse trigonomic functions. Now, okay, it means a lot. Anyway, alright. Okay, so when we look at this, I know this is some booty right here, but I want you guys to pay close attention to this piece right here. So this piece right here says g prime of y naught. Okay, so that means that is the y value is equal to 1 over f prime of x naught. So your initial x and initial y. Okay, so these are reciprocal, or not, yeah, they're reciprocal for this. So when you have this, you have your x value here, you have your y value here. Notation's weird, okay? But, you know, after we do the first problem, you'll be like, oh, it's not that bad. Okay, so now for this one right here, it says the function here has an inverse function g, all right? So the inferred function g. So if I take that information I had, I know that it was my g prime of, that would be my y naught, right, is equal to 1 over f prime of x naught, right? What? Would it be negative on the left? No. Why? Isn't that a negative right there in front of the g? You mean that equal sign? The equals, it's kind of weird. It's faded. It's like the bottom one is faded.
Oh, okay, I see. I'm black.
It's all right. You know what? I'm not judging on that one. All right. Okay, so now, so the values are, so that means that 2 is the y value, right? So 2 is the y value, so I need to figure out what is the x value, right? If 2 is a y value, I need the x value. So I know that right here, 2 has to be equal to x to the 5th plus 5.
Yeah.
X. Dang it.
Okay.
Come on, brain. Come on. Come on. Okay, so x, x, x. There we go. Ooh, all right. So now, so I'm not going to make this complicated of effing that and, you know, doing this and doing that. What is my value for x that's going to work here? 1. Right?
Yeah.
Yeah, that's the only thing that's going to work here. So 1. So x has to be 1, isn't it? So we're saying that for this one right here, so my point is I'm going to have 1 here when my y value is 2, right? So if I plug in 1 for this, I get a value here, right? Okay, so now I don't have a function for g. I do not, right? I don't have a function of g, and I'm not going to go and try and, you know, do an inverse of it. I'm not going to try and turn it inside out, okay, to make it x equals something in terms of y. I'm not going to do that. So I have a function for this. So now, so this is saying that I have to do g prime of 2. That would be the same as saying 1 over, come on now. Okay, say f prime. F prime of 1. Okay, that's why I said you had to pay attention to these pieces right here. You have to pay attention to those because this is the y, that's the x, right? Okay, so now I can do this because I now am trying to find the value for this by using this. Can we find the derivative of f? Yes. So this is going to be the same as saying 1 over 5x to the 4th plus 1, right? Yes? Yes. And now I can plug in for 1, right? Yes. So if I plug in 1, that's going to give me 1 over 6. So the derivative of g at 2 is 1 over 6. Okay, this is some mumbo jumbo where we're switching x's and y's here because I'm looking for the other value. Okay? All right, let's try this one right here. The function here is 1-to-1. It has an inverse function g. Okay, find an equation of a tangent line to the graph of g at the point here. Now, I'm trying to find the inverse, okay? Okay, find the equation of the tangent line to the graph g at that point. So now, for this one, I'm gonna have the point on g. So this one is slightly different, so it's gonna be, oh crap, I'm trying to remember. Because this one, because it's looking for the tangent line right here. Am I on the right one? No, I'm not on the right one. Now I'm on the right one. Am I on the right one? No. Am I? No. Is this the right one? No, this is not the right one. So we say that for this, it has that g of 8 is 2 and f of 2 is 8. I'm making sure because this one's a weird one because I don't want to screw this one up too bad. So with the tangent line of gravity, okay. So I'm looking for g prime of 8. So okay, so now for this one, now because on my previous one, okay, I was already given this value here, right? I was already given for that value there. So what I was plugging in, you know, for this, I already had a number for this. But for this, I'm looking for g. Oh man, I even said g. I'm looking for g prime of 8, which is going to give me 1 over f prime of 2. Now, on the last one, we knew at that point 2 is what I was looking for, and I had to try and go back and find it. So I know from this, I'm going to actually be finding this value. So from here, I'm going to go through and find my derivative. So my derivative is going to be 1 over 3x squared plus 2. And then that's going to give me at 2 here. So that's going to give me, let me see, that's going to be 4, 12, 14, right? Yep. 1 over 14. Now the 1 over 14 represents my what? Say slope.
So yeah, slope is the derivative.
Yes, okay. So it's going to be the slope, right? So since we're finding of this right here for the g prime, and we're having at this, so, yeah, for this here. And then I have the point there, so it's going to be y minus 2 equals 1 over 14 quantity x minus 8. So we can go through, do the math. So that's y equals 1, oh, come on now, 1 over 14x minus 8 over 14, and that's going to be plus 28 over 14. Just have to combine those last two, which is going to give me 20 over 14, which is 10 over 7? Yeah, positive 10 over 7. So this comes up, y equals 1 over 14x plus 10 over 7. All right, so let's go through a couple things that we have. Inverse sines. So this one's actually right here. So inverse sine, this is actually really important because you don't, that's an identity right there. Treat it like it's an identity. You don't want to actually have to work this out. There's a proof for it, and I don't want to do it. Okay. I kind of like doing the math sometimes when you're like, hey, let's do the math on this. Like, how fast does Michael Phelps actually swim? Okay, so it's not very fast. Only, was it like 4 miles per hour or something like that? 5 miles per hour. Anyway, so that's a brisk walk. Anyway, all right, so right here, we're going to use that. Okay, so my next problem, which did not make it on the paper here, was supposed to be, here it is. Y equals inverse sine of 4x squared. Okay. What rule would that be? Chain. That is chain. What's the derivative of the inside?
8x.
Okay, so y prime would be 8x times, what's the derivative of the outside? Use the identity we just had.
1 over 1 minus
Say radical.
rad 1 minus x squared.
Okay, but.
Because it's the x we're going to
Okay, what is my x in this case?
It's going to be 4x squared, so 4x to the 4th.
Okay, close.
16.
16x to the 4th. Okay, because all this right here is my x in that one right there, right? So I took it, squared it, and I got that. And the only thing I would do is actually clean up the bottom, or clean it up, and just put 8x over the nastiness of 1 minus 16x to the 4th. It's not too bad, right? All right, so let's see. I think there's one more of those. Okay, let's y equals e to the inverse sine of x. Yeah, let's try that one. This one again is a chain, right? Okay. So what's the derivative of this, the top?
1 over rad 1 minus x.
Okay, so it's 1 over 1 minus x squared times, what's the derivative of e to the x?
E to the x. So
But in this case, it's going to be e to the
inverse sine.
inverse sine of x. The only thing I would do is just clean it up and put that on top of the where that one's at, right?
Yeah.
Okay. All right. So next problem has another rule. This is for you. So we have that tangent. So we're going to be using this one. Okay, so if we're using this one, my first problem I have is inverse tangent 4x. All right. So for this problem right here, what rule do I use? Chain. So derivative of the inside? 4 times
1 over 1 plus 16
Yep. So this turns into 4 over 1 plus 16x squared.
There we are.
It's not bad, right?
No.
It's just something new. It's something new.
So is that the flash?
Yeah. Sine inverse tangent x. So this next one is going to be
Is sine inverse or is that?
no.
Do the chain rule. So
Okay.
y prime equals 1 over 1 plus x squared times the derivative of the outside, which would be cosine of that. Tan.
Of?
Yeah, inverse tan. X.
Right? And all I do is put that in front, right?
Yeah.
Over.
On top.
Yeah. It's not bad, right?
No.
Alright, so this next one is, let's go. Oh, it's less than 1, not 0. Okay, for that first one, why does the absolute value of x have to be greater than 1? Okay, it's got to be greater than 1, because if I have 1 minus 1, that will give me 0, right? And so I'll end up with a 0 on the bottom. So it can't be equal to 1, right? But why is it got to be greater than 1? Negative, that radical, right?
Yeah.
The domain. So if it was it's gotta be more than that, right? Cause if it's less than one, that means that the negative one would be bigger, right? So I'd end up with a imaginary number there. So that's outside of my domain, so that's why. Same thing for the second one right here for cosine. So where x, absolute value of x has to be less than 1, because if it's more than 1, then I'm going to end up with a negative inside my radical. And for this last one, cosecant, absolute value of x greater than 1, again with where the restrictions are on my domain here. Alright, so now you guys are just going to use these, you know, it's the exact same thing as what we've been doing, but you're going to use this. So every time you see one of these, you're going to use this as part of your derivative. Okay, and I should be getting you guys the flashcards tomorrow. Alright, so that's it. Don't forget, like and subscribe, right?